This is a video on using the AC method. You want to use the AC method when you're factoring expressions of the form ax squared plus bx plus c where a doesn't equal 1. So you're factoring a trinomial, meaning it has three terms, and a, b, and c are all constants. A is the leading coefficient. Really what we're saying is that a can't be 1. Alright, so a is any number other than 1 here. Alright, so that's what this note says. The steps to factoring in this form are, first, determine if a GCF exists. If so, you want to factor it out. Sometimes there will be, sometimes there won't be. But if there is, factor it out to the front and then follow the steps as normal for what's left over. Step 2, you want to find two numbers whose product is equal to AC. When I say product is equal to AC, you want to multiply what A times C is, figure out what that number is, and you want to find numbers whose product is equal to that number. So A times C is coming from A times C up here in the expression, and whose sum is equal to B. So we want numbers that multiply whatever AC is, and they also have to add to whatever B is, the middle coefficient. Step 3 is very important. This is what sets the AC method apart from other methods. The AC method is really a rewrite method. It's a way of rewriting the middle term. And it's important to know that you're rewriting here. So you're rewriting the middle term, the bx piece, using the numbers that you found in step 2. Alright? Note, and this is an important note, this is not a factoring step. You're not factoring right away. The AC method is really a method that helps you rewrite a trinomial into 4 terms. So you take something that has 3 terms, you rewrite it in terms of 4 terms, so then your last step here, use factor by grouping, because that's what we use when we have 4 terms. Now let's take a look at a few examples. So the first example, we're going to factor 4x squared minus 13x plus 9. First off, we have 3 terms here. Alright, so that's good. You're looking for a GCF for the entire expression. In this case, all 3 terms don't have a common factor, so you can't factor anything out. So you have 3 terms, there's a number in front of x squared. That tells you that you're going to use, the AC method. Alright, so when you have 3 terms and a number in front of x squared, that's what's going to tell you using the AC method. And for the AC method here, we want numbers that multiply to AC. Alright, that's what our steps to do. We want numbers that multiply to AC. Well, AC is, this is A, 4 is A, and C is a positive 9. So we want numbers that multiply to whatever 4 times 9 is. So we want numbers that multiply to 36, and they also have to add to whatever the middle coefficient was. They have to add to B. Well, B is a negative 13. So they have to add negative 13. The numbers that multiply to 36 and add to negative 13, so those numbers are a negative 9 times a negative 4. Negative 9 times negative 4 is a positive 36. Negative 9 plus a negative 4 does equal negative 13. So we found these numbers. Remember, these numbers are unique. There's no other way of finding the numbers. So these are the numbers we have to use, negative 9 and negative 4. This is the most important part. This is a rewrite step. Our W here stands for rewrite. Alright, it's a rewrite step. You are not factoring right here. You're rewriting the middle term. The middle term being a negative 13x. The ends will stay the same. So we have 4x squared. And now negative 13x is going to get replaced with the numbers negative 9 and negative 4. And since this is an x after it, x is going to come along. So it's a negative 9x. Alright, and then minus 4x. That's replacing the middle term. And then the plus 9 on the end stays plus 9. Now the reason we're allowed to do this is because negative 13x is equal to a negative 9x minus 4x, right? That's the same as a negative 13x. So looking at that, that means that we can really separating negative 13x up into 2 terms, negative 9x and negative 4x. But you have to do it systematically. You can't just pick whatever numbers you want. That's what the AC method does. It gives us a systematic way of picking how we break up that middle term. Once we've done that, alright, now we're ready. We have 4 terms. We're ready to factor by grouping. And you want to take out a GCF from each group. From the first group of 2, we got 4x squared minus 9x. Well, the 4 and the 9 don't have any common factors, but x squared and x have an x in common, so we're going to factor an x out of those. A negative 4x and a positive 9, they don't have any other numbers in common other than 1. Alright, and this doesn't have an x with it, so the only thing you can factor out here is a 1. And since this first term is negative, remember from factoring by grouping, the first term being negative tells you you're factoring out a negative. Since these have a 1 in common, you're going to factor out a 1 here. And you have to do that because otherwise we won't be able to finish our factoring by grouping. So you're factoring out a negative 1. So factoring by grouping means we take out our GCF from each group of 2. So we're going to have, from the first group, we're factoring out x. So you're going to have x out in front. 4x squared factoring out an x means, remember, you're dividing it out, so it's just 4x. Negative 9x dividing out an x gives you just negative 9. So it's factoring the x out of that first group. Next, we want to write our GCF of the second group, which is a negative 1. Remember, the negative came from that first term, and you have to have it there, so it's a negative 1. All right, times, if I divide out a negative 1 from each term, a negative 4x divided by a negative 1, that's what you're doing when you're factoring it out. A negative divided by a negative makes it a positive. All right, and then 4x divided by 1 is just still 4x. So it's a positive 4x because we did a negative divided by a negative. Here we get a positive 9 divided by a negative 1, so it's going to leave us with a negative 9 here. Once you're here, you've created two terms that have a common factor. In other words, what matches here? Well, 4x minus 9 matches with 4x minus 9, so we're going to bring that out to the front. And then what's left over for each term? Well, we have x and then minus 1. And now we factored it. Alright, you have two things being multiplied together, so it's factored. You could always check this by foiling and making sure you get the original statement. Another note that I have to make here is that, the order that I made this negative 9, negative 4, it doesn't really matter here as long as you have them with the correct signs on them. So you could have wrote this as negative 4x minus 9x. The middle steps would have looked different, but you'd get the same answer in the end. Let's take a look at another example. So we have 8x squared minus 26x minus 27. The first thing you should look for here is to make sure that if there's a GCF for all the terms that appear. And in this case, 8x squared, 26x, and 7 don't have any common factors, so there's no GCF to factor out. We have three terms, and the coefficient of x squared, the leading coefficient, is 8. So it's not equal to 1. That's what's telling us that you have to use AC method. There's a number in front of my x squared there. And remember, we want numbers that multiply to whatever AC is. Well, AC is equal to, remember, A is whatever's in front of x squared, so it's 8 times negative 7 is what C is. All right, make sure you take the sign with it. So we want numbers that multiply to a negative 56, and they also have to add to whatever B is, the middle coefficient, which is a negative 26. All right, so numbers that multiply to a negative 56 and add to a negative 26, well, those numbers are going to be a negative 28 and a positive 2. Because negative 28 times 2 does give us negative 56. Negative 28 plus 2 does give us negative 26. Remember, these numbers are unique. Now, once we have these numbers, remember, the next step, and it's very important you realize this, is a rewrite step. Alright, you're just rewriting this original expression, and what you're rewriting is the middle term. You're breaking up this middle term based on the numbers you found here. So the ends are going to stay the same. So you're going to have 8x squared. All right, and then minus 26x is what we're replacing. We're replacing with the numbers we found here, and then since this has an x after it, you're just going to put x after each of them. So it's going to be minus 28x plus 2x, and then minus 7 stays on the end. So we replaced the negative 26x with negative 28x plus 2x, which is okay because negative 28x plus 2x does equal negative 26x. Remember, you have to find these numbers systematically. You can't just break them up however you want. Alright, once we're there, we've got four terms. When you have four terms, remember, you use factor by grouping. So we got this group of 2 and this group of 2. This first group of 2, common factor between them, well, we got 8 and 28, so the GCF between those will be 4, and then x squared and x have an x in common, so it's going to be 4x. The GCF between the second group of 2, we got 2x and a negative 7. 2x and 7 don't have any common factors. Alright, if they did, you would factor it out, but since these don't have any common factors other than 1, we're going to factor out a 1, and it's a positive 1 because the first sign is positive. It's always based on the first sign, remember. Now we're going to factor out the GCF from each group. So I'm going to have 4x here being factored out of the first group. We got 8x squared divided by 4x. That's what you do when you factor it out. 8 divided by 4 is 2. X squared divided by x just gives you x. And then we had a negative 28x divided by 4x. Negative 28 divided by 4 makes it a negative 7. X divided by x cancels out to a 1. So we have 4x times 2x minus 7 just from that first group. From the second group, remember, you're going to write whatever the GCF is out in front with the sign. The sign is a positive because of that sign, so it's a positive 1. And then parentheses factoring out a 1. Well, 2x divided by 1 is just 2x. Negative 7 divided by 1 is negative 7. All right, once you're here, all right, now you've got two terms, each with something in common. 2x minus 7 is what they have in common, so that's what matches. That'll go in front. Times, in your second set of parentheses, whatever's left over, so it's 4x plus 1. And then you have it. It's factored. You could always check this by foiling, remember, and making sure you get the original expression. All right, let's take a look at a few more examples here. If I said to factor (8x squared minus 2xy minus 3y squared). The first thing I want to look at here is if there is a GCF for the entire expression, I would want to factor it out. In this case, there isn't, so there's nothing to factor out. And then remember, when you're factoring a trinomial, something that has 3 terms, right? So you count that it has 3 terms. You look in front to see if there's a value in front of your x squared. In this case, there is, right? A value other than 1. So that tells us that we might want to try using the AC method. So remember, for the AC method, I want things that multiply to AC. Remember, this is A, B, and C. Don't let the variables throw you off, right? I'm really talking about the coefficients. So when I say multiply to AC, I want things that multiply to 8 times -3, which equals -24. And they also have to add to B, right, the middle coefficient, which in this case is -2. And you want to find numbers that do this. So, you want to be careful with numbers that multiply to 24s. So for a -24, I know that the signs should be opposite of one another to multiply to a negative, right? So 1 positive, 1 negative. To add to a -2, I know the larger value should be negative, and the numbers that do this are -6 times +4, right? -6 times +4 gives you -24. -6 plus 4 equals -2, so I found the numbers. Now remember what you're doing with these numbers. The AC method is a rewrite method. You're rewriting that middle term. The ends stay the same, so when I go to write this over here, I'm keeping 8x squared as 8x squared. I'm replacing the -2xy with the numbers I found, so the -6 and the +4, but make sure you put xy in there. That's what makes these like terms. So you're really splitting up that middle term into 2 terms. So -6xy, and then a +4xy. And then you have -3y squared, again, stays the same, right? So the ends stayed the same, only the middle was rewritten. And what you're really doing is you're taking apart that middle term as like terms, but in a strategic way. You can't just use any numbers you want, right? So in a strategic way, we've separated that. Once you're here, you have 4 terms. And remember, when you have 4 terms, that's where we use factor by grouping. So I'm going to make this 2 groups of 2. From the first group, you're going to look for a GCF. So between 8 and 6, we have a 2. X squared and x have a common factor of x. You can't take any y's out because they only belong in the second term. For the second group of 2, you have 4xy and a -3y squared. We know it's a positive value we're factoring out because the first term is positive. 4 and 3 don't share any factors other than 1. We have an x here, but no x's here, so we can't touch any of those. We have y and y squared, so we need to take y. Remember, you want the lowest power you see. So when I go to write this, I have 2x factored out from the first group. 8x squared factoring out 2x really means divide by it, so you end up with 4x. -6xy divided by 2x makes us -3. The x's cancel. Y's still there, though. Don't lose that. And then here, this is a positive y. Make sure you put the sign there, right? That's an operation, so it's plus y. This is a minus. You take out a negative y, you put minus. But in this case, it was positive, so you put plus y, and then you factor the y out. So positive 4xy divided by a positive y. The y's are going to cancel yourself with 4x. Here, -3y squared, factoring out the y. The -3 stays. Y squared factoring out one of the y's leaves you with 1 left. And remember what you're doing. You're trying to factor. You want a product at the end of it. So you don't stop here. You want to notice that they have 4x minus 3y in common. If these aren't the same here, you can't go any further. These factors that you're trying to pull out have to be the same. So we pull out a factor of 4x minus 3y to the front, and you're left with whatever's left over when you factor it out. 2x is going to be left when you factor out the 4x minus 3y from the first term, so you got 2x. Plus here, factoring the 4x minus 3y out from the y times it is just plus y. So you're basically just taking the front of each of these and it goes inside the second set of parentheses. Parentheses around both, you have a product now, so you're good. All right, so the answer, the solution is 4x minus 3y times 2x plus y. Let's take a look at another one. If I had said to factor 8x squared plus 8x minus 6. First thing when you're factoring you should be doing is looking for a GCF, a greatest common factor. In this case, I do have one, right? 8, 8, and 6 all have a common factor of 2. You can't take out any x's though because the first two terms have x's, the last one doesn't, so you know x's. So just the GCF of 2. Remember when you factor a GCF out to the front, it stays in the front, and then everything else gets divided by that to figure out what's on the inside. So 8x squared divided by 2 gives me a 4x squared. 8x, factoring out 2 makes us plus. Make sure you keep the sign with it. So plus 4x, and negative 6, factoring out the 2 makes us negative 3. Now remember, when you take out a GCF, right, when you factor it out, it stays in front in the entire problem. If you don't take it out at the beginning, it'll be buried somewhere in here at the end. So we take out the GCF in front, it stays in front. And then within these parentheses that are after it, we do what we normally would do. So if I was looking at this, I notice I have 3 terms, right? So you want to count the number of terms. I have 3 terms. When I have 3 terms, I want to look at the leading coefficient. If I see something other than 1, which I do in this case, that tells me I might want to use AC method. So remember to use AC method. Things that multiply to AC. You're doing it on what's inside the parentheses, not the original problem. So, right, A, B, and C, we're talking about the coefficients. So A times C is really 4 times negative 3. So AC is actually equal to negative 12. And you want things that add to the middle coefficient, which is B, which is positive 4. So we're looking for numbers that multiply to a negative 12 and also add to a positive 4. So finding those numbers, numbers that do that, to multiply to a negative, you don't have to have opposite signs. Because you're adding to a positive number, the larger one should be the one that has the positive sign on it. So we get 6 times negative 2. That gives me 12. 6 plus negative 2. That does give me positive 4. So that checks out. So remember, AC method is a rewrite method. You're rewriting the middle term. The ends stay the same. So this stays 4x squared. All right. Plus, now the 4x gets replaced with the sum that you have here, right? 6 plus a negative 2. But make sure you bring x with each term because you're going to use those as like terms. So this replaces the 4x as plus 6x minus 2x. And then the last term stays negative 3. Make sure you keep it in that order. So once you've written the terms back out, make sure you have x on both of these. Don't combine them back together, right? You don't want to get back to a 4x there. The idea behind this is to split those up because now we know we have 4 terms in here. So when you have 4 terms, remember you want to group. So 2 in front stays 2 in front, and these big parentheses we're going to keep here. From here, we're going to do grouping because we have 4 terms on the inside. So for the first group of 2, 4 and 6 share a common factor of 2. X squared and x share a common factor of x, so we can take out 2x. For the second group of 2, we know the first term is negative, so we know we need to take out a negative for sure. 2 and 3 don't share anything common other than 1, so we got negative 1 there. And there's no x's in the second term, so we're just going to take out a negative 1 from there, and that's okay, right? 1 can be a common factor you factor out from here. This case it's negative because the first term's negative. It has nothing to do with the second sign, it has everything to do with the first sign. So when you write this out, you end up with 2x times, when you factor it out of here, you have 4x squared divided by the 2x gives me 2x. We have a positive 6x factoring out the 2x, so it's positive just 3 because the x's are going to cancel. Close those parentheses. This negative 1, remember, stays negative 1 here, and then you factor it out. You're really dividing, and negative divided by negative makes us a positive. 2x divided by 1 is just going to be a positive 2x. A negative 3 divided by a negative 1 makes us a positive 3. Close that parentheses. Now you have this big set of parentheses separating the 2 from everything else. Remember, the GCF of a 2 in front stays 2 in front. And then within here, right, when you're doing factoring by grouping, you look for a common factor to both terms. In this case, they have a 2x plus 3 in common. And then what's left over from the front of each of these? Well, that's the 2x minus 1 when you factored out that 2x plus 3 from each one. Because this is all a product, you don't need the big parentheses anymore. It's all multiplied together. and that's your solution at the end. Keeping in mind that when you do this, if you don't put this big parentheses separating that 2, you're going to get different values in here, and it'd be incorrect. The other thing to keep in mind is that maybe at the beginning of the problem you forgot to look for a greatest common factor, so you didn't take the 2 out. The AC method would still have worked, the numbers would have been larger, but the AC method would have still have worked, and it would have felt like you factored the whole thing. But at the end of the problem, that 2 as the GCF would have been buried in one of these factors. You'd end up with, either this 2 being in the first set, which would have given you 4x plus 6, or in the second set, would have given you 4x minus 2. You would have had to have noticed the GCF was there and factored it out. Otherwise, you wouldn't have factored completely and you wouldn't get full credit. So that's why we always take the GCF out first, to make sure that you actually have, it factored completely by the end of the problem. Let's take a look at a couple more here. So if I said to factor 15x squared minus 99x minus 42. First thing when you're factoring, look for a GCF. So in this case, 15, 99, and 42, do they have a greatest common factor other than 1? And the answer is yes, it does. 15, 99, and 42 might not be obvious, but they share a common factor of 3. If you can factor a GCF out, you factor it to the front at the beginning of the problem. Remember, you're just dividing it from each term. So 15x squared factoring out the 3 leaves me with 5x squared. Negative 99x factoring out 3 leaves me with negative 33x. And negative 42 factoring out the 3 leaves me with negative 14. We'll close the parentheses there. Remember, when you take a GCF out to the front, it stays in front for the whole problem. And then I want to work on the inside of this. I count the terms I have. I have 3 terms here. And do I see a value in front of x squared other than 1? And you do. Your leading coefficient, when you have 3 terms, if you have something that is something other than 1, you can use the AC method. So I'm going to use AC method inside of here. So 3 is getting separated from this, whatever my result's going to be. And remember, you're using AC method on the inside of this, not on the original problem. So we want things that multiply to A times C, which is 5 times negative 14, which equals negative 70. And you want things that add to whatever B is, the middle coefficient, which is negative 33. So we want to find numbers that do that. It may not be obvious. It might be challenging to come up with these numbers. I mean, you have to try your multiplication facts. You have to think about how to find factors for a number. But the numbers we get here that do this are negative 35 times a positive 2. The signs have to be opposite because they have to multiply to a negative. So negative 35 times 2 does give me negative 70. And negative 35 plus 2 does give me negative 33. So this is me just checking to make sure I got numbers that do this. You don't necessarily have to show this part if you know it, and you can just substitute in right away. But if not, you should show it because it might help you out. Once we have that, remember how this works out. The ends stay the same. So 5x squared stays 5x squared. The middle, the negative 33x, the AC method is a rewrite method. It's a way to rewrite the middle term. So if I want to rewrite negative 33x, remember you use the values you found, but keep the variable part the same. So you're going to write this as negative 35x plus 2x. It's kind of like uncombining like terms. And then negative 14 stays negative 14. Remember, the ends stay the same. The middle is what's getting replaced. Make sure you have the variable with both of them. Once you've done that, now we're ready to move on. 3 in front stays in front. Inside these parentheses, remember, now I'm doing factoring with 4 terms. When I have 4 terms, I use factor by grouping. So when I group these, remember how it works. Group the first 2, group the second 2. So 5x squared minus 35x, the GCF, the 5 and 35 share a 5. The x squared and the x share just an x. So 5x is the GCF for the first group. For the second group, 2x minus 14, the first term's positive, so I know I take out a positive value. 2 and 14 share a 2 in common. This has an x, the second term doesn't, so you just can take out a 2. Factoring from each term. So factoring a 5x out from the first group of 2. 5x squared factoring out 5x just gives me x. Negative 35x factoring out the 5x gives me negative 7 because the x's are going to cancel. Close the parentheses. This is a positive 2. You need this plus sign. If you don't have it, you won't get full credit. So plus 2 times, in parentheses, when you divide 2 out or factor it out, 2x divided by 2 gives me a positive 1x. Negative 14 divided by 2 gives me a negative 7. Remember, the 3 is still separating all that. You need this big set of parentheses around it. Moving to the last part of the problem, 3 in front stays 3 in front. Remember that GCF is always staying in front. And now when you're factoring this, remember on the inside you need to have a common factor here, which these are x minus 7 times x, or x minus 7 is the common factor for each of these. So you can take x minus 7 to the beginning by factoring it out, and then you're left with whatever's in front of each in the parentheses once you factor it out. So 5x plus 2, because you're factoring x minus 7 from each term. You don't need the big parentheses anymore because now it's all a product. It's all multiplication. So this factored down to 3 times x minus 7 times 5x plus 2. So a couple things to point out. First off, if you didn't take out the GCF of 3 at the beginning, you could still get something that would factor using AC method. The numbers would be very large. But then the 3 would have been buried in one of these factors, so you would have had to factor 3 at the end. It's always important to take the GCF out first because it makes it so you can have smaller numbers to work with, but also to make sure that you factor completely at the end. The only other thing I would mention about this is that, you know, if you switch the order of the negative 35x and the 2x, just make sure you keep the sign with it. You put a positive 2x here, a negative 35x here. It would still factor. It would look differently in the middle steps, but at the end it would factor out to the same values. I just want to do one more example just to kind of show the difference between something we did earlier. If I was to factor this, 4x squared minus 12x minus 16. First thing you want to do when you're factoring is look for greatest common factor. In this case, there is a GCF. 4, 12, and 16 share a common factor of 4. So I'm going to factor 4 to the front. And then in parentheses, what's left over is whatever you have. 4x squared factoring out to 4 gives me x squared. Negative 12x factoring out to 4 makes this negative 3x. And then negative 16 factoring out to 4 makes this negative 4. And then your next step should be to look inside, right? So here I'm left with 4 in front. And then in the parentheses, I count my terms. I have 3 terms. And then I look at the leading coefficient. In this case, the leading coefficient is 1. If the leading coefficient is 1, right away you should make 2 sets of parentheses. You should not be using AC method. AC method's for when the leading coefficient isn't 1. If the leading coefficient is 1, then you can make 2 sets of parentheses and put the x times x for the x squared when you reverse FOIL it. And you want things that multiply to the last term, remember? So multiply to negative 4 and also add to the middle coefficient, which is negative 3. Finding the numbers that do that, you would get negative 4 times 1 gives you negative 4. Negative 4 plus 1 gives you negative 3. So you could just substitute in with x minus 4 and x plus 1. And then it's factored. You shouldn't do an AC method on something that looks like this, because if you did, you'd be spending a lot more time just to get to the same answer. It would work, but you're going to be spending more time to get something that's meant to be a much quicker problem. The other thing is at the very beginning, if you don't look for a GCF, you might have tried AC method here. It would have worked, but then you would have to have factored out a 4 at the very end of the problem. So if you have 3 terms and the leading coefficient's a 1, you want 2 parentheses right away. You can put the x squared in each of the first slots in those factors. If you have 3 terms and the leading coefficient isn't a 1, you know, that's after factoring out the GCF, like these other problems we've done, that's where you want to use AC method. So hopefully that is clear and makes things a little easier in terms of factoring, and I hope this video helped out.